Okay, welcome to Sydney and Josh and Josephina and Melanie and Kristen and Jacob and Jean and Xavier. I don't think, hopefully I didn't miss anyone, but I think I got everyone. There could be others coming. This is the week 3, the first of 2 week 3 webinars. And what we're going to do today is, today's a content day. We're going to be looking at chapters 4 and chapters 5. They're shorter chapters. We don't do everything from the chapters. We just do in chapter 4, we do discrete distribution, we do a expected value and standard deviation of a discrete distribution. We also do binomial distribution. And then in chapter 5, we do the uniform distribution. So that's a plan. Just to note, tomorrow is a different webinar. This is one of the weeks that we have 2 different webinars instead of 2 of the same. So you do want to join in tomorrow if you can. Otherwise, I'll have both of these recorded, posted on the YouTube channel that I've got. And the idea is tomorrow's a really important one because it's the project. So hopefully you all have partners, okay? Not just the 8 of you, but also the other 38 people in the class. Real important to get partners. I recommend 3 in a partnership. 2 is allowed, but 3 is better. So again, partners are very, very important to get. Let me ask, are there any questions before I start up? Any questions? Okay, let me start up. I want to start up with a little current event. Okay, it won't look that current, but it is current because it is important to understand why we use this stuff. And I thought I would bring in, hopefully you can see this. So this is Noah. I don't know if you know of Noah, not the guy with the ark, but Noah as in national, basically, organization on some kind of atmospheric stuff. So anyway, they're the ones that kind of look at the global temperatures. And if you look, this is a report, and it says data shows 2016 warmest year on record globally. Of course, 2017, we'll find out what happens, but we're not there yet. We're in 2017, but we can't talk about the entire year yet. But what we can do is we can say, well, what is 2016 happening? What's going on with it? Let me go there just a minute. Pop in all the chat stuff. And I want to calculate a little probability. So what it says, most of the warming occurred in the past 35 years, with 16 of the 17 warmest years on record occurring since 2001. Okay, so 16 of the 17 warmest years on record occurring since 2001. What I want to do, since this is a statistics class, is see what is the probability that that would happen, given that they're independent. Okay, and that is a bit of a given, but what is the probability that that would happen given they're independent? One thing you have to look at is if you scroll down a little bit, it will say, this is from 1880 all the way up to 2016. So if you count the number of years, that's 137 years of data. Any questions on that? But I want to get paper, so I don't forget. So we have 100. So we have, again, 1880 to 2016 is 137 years of data. Okay, so if you look at the top 16 years on record, the probability that you are going to be any given randomly selected year in the top 16 years, hopefully you all understand that's 16 over 137. Any questions on that idea? So if you look at any specific years, the probability that it will be in that top will be 16 out of 137. So now let's find out what is the probability in kind of, if you look at 17 consecutive years, that at least 16 of them will be in the top 16. Any questions on the question? Okay, again, we're going to assume everything's independent. So what we need to do is we need to find out, how do you compute such a probability? So we're looking at year to year, and if it's independent, the probabilities each year should be the same to be in the top 16 out of the 137 years. So we can talk about a binomial probability. Okay, any questions on that so far? So if you have a yes or no question, and the question is it in that top 16? That's a yes or no question. And we want to find out the probability that at least 16 out of 17 years are in those top. Okay? Any questions on that? Okay, actually, if it's in the top 17, the probability would be that 17 over 137. Sorry about that. So 17 over 137 is the probability that something will be in the top 17 warmest years. So what is the probability that if you take 17 randomly selected years, at least 16 of them will be in the top 16? Okay, and that takes some work. So first thing is, this is a binomial. And with our calculators, for most of the calculators that we've got, like these guys, it doesn't do the at least. So if you want at least 16, you have to think about it in kind of the opposite direction. So at least 16, if you think about, say, 14, 15, 16, 17, at least 16 is 16 and up. We want downwards, so we could take the complement of 15 and down. The complement of 15 and down will be 16 and up. Any questions on that idea? Okay, so now we're ready. We use the rule of complement, saying the probability of something happening is 1 minus the probability of its complement. So I'm going to pop in the calculator. It'll take me a minute. I'm a little slow today because my computer crashed just at the wrong time, just as I was preparing for this, but I'm back. Okay, so now I'm going to go new share, calculator, and hopefully you can see this. Okay, you should be able to see it now. Let's clear this out. Okay, so what I'm going to do is I'm going to go 1 minus, and I want you to all do this together if you have your calculators with you so you get used to it. And now I'm going to go to second distribution. I'm going to use the up arrow because it's a little faster. And I'm going to go to binom CDF. C stands for cumulative. So we're accumulating all the numbers from 0 to 15. I'm going to hit enter. This kind of calculator asks for trials P and X value. If you have the older kind of calculator like the TI-83 or the older TI-84, then you're going to type in, it'll just show binom CDF, and you're going to type in what's called N, P, and X. I like to think about it alphabetical. N will be the number of trials, which is 17. P is the probability of it being in the top 17, which will be 17 divided by 137. And X will be what we're looking at. And remember, we're taking the complement of 15 or less. So 15. And then just go to paste. And then let's hit enter. And what does it give us? Okay, so how high is this probability? What do you think? Do you think there's a 0% chance? Do you think the calculator's correct? What do you think? Put in the chat box or talk, one or the other. And if you talk, you got to kill your mute and make it unmute. So do you think the calculator is correct in that the probability is exactly 0? Okay, it's not correct, but it's about as close to correct as you're going to get. Okay, there's a much higher chance of winning the lottery than to have this happen. So when we have that in science, we're talking about less than 1/trillionth of a percent, 1/trillionth of a chance, which means it's pretty much damn unlikely. So when that happens, you pretty much say that it's clear that this isn't random chance. Any questions on this idea?
Okay, I'm having a problem, like, when I was like, okay, I stopped at 1 minus because I'm trying to like press second and it's not going through on my calculator. I don't know what's the problem.
Okay, so the exact buttons you hit should be 1, first clear everything out, and then
Okay.
1, and make sure you hit the minus key that's 2 above enter, not the 1 on the bottom.
Yeah.
Okay, just wanted to, I'm thinking about all the things that can go wrong. So it's the subtraction, not the negative.
Mm-hmm.
And then you hit, right after that, you hit second, that's that blue key, and then distribution, D-I-S-T-R.
Yeah, mine's it's not coming up.
It
The
should.
second, it's like, okay,
It's hard to
1.
see on your screen.
Can you see?
It's kind of fuzzy. Sorry. Try it without the 1 minus, and then we'll do the 1 minus after. You could do the 1 minus by, later on. So just go second, and then VARS, and it should give you that right there. Are you getting there?
Yeah, it's still not working. There's nothing coming up.
Nothing coming up?
Yeah, look.
Okay, so you might want to turn it off and turn it back on. The old, foolproof way of making a calculator work. And then start again, hit clear. So hit clear, and then hit second, and then this VARS, which is the distribution key. See if that works. And Melanie, you don't live in Tahoe, right?
No.
Okay, so it's going to be hard for you to come to my office. It's one of those, sometimes it's easier to physically.
Yeah, I think it's I don't know, it's still not working, so.
Okay, I might try and help you after so I don't waste everyone else's time. So maybe when we're done, I got some other things to do, but they take some time.
Okay.
Okay, it might be some settings, so I might have to look at that. Okay, but for now, any questions at all on at least the statistics that we're talking about? So there's pretty much as close to 0% chance as you can get for this to just be random. So it is undeniable evidence that we're in a period of global warming, okay, where we have our Earth has warmed up. Any questions at all on that? Okay, so now what I want to do is I want to do some more stock problems. I always like to bring in one current event if I can, and that was our current event. Now I want to go to that one. And it might take a moment. Can you see it yet? You can see it? Okay. So you should be able to see, write down the probability distribution for the following. Can you all see that? Okay. If you can't, let me know. Okay, so let me read this out, and we're going to work this out. Okay, it says a car salesperson gives out a $10 gift to every customer who test drives a car. 12% of all customers who test drive a car purchases the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchases a deluxe model of the car, resulting in a $300 commission for the salesperson. It's a typical kind of job that somebody would get in sales, commission-based sales. So let's write down a probability distribution function for the salesperson's profit, and let's find the expected value and standard deviation and interpret. And what do you think about this job, good or bad? So what I want to do first, I'm going to do what's called a probability distribution table. So I'm going to go to Insert, Table, and, ooh, just a minute. Let's do it over here. There we go. Now let's go Insert, table, and it'll like it a lot better. Okay, notice that there are 3 different things that could happen. So I am going to go like so, and I'm going to do some labels. So the first label, and you could do rows or columns, a little easier to do rows when you're doing typing and stuff. It just fits better on the page. The screen between your calculator, NASA, and Word doc are blipping out hard for me. Okay, the hope is you shouldn't be seeing the NASA.
Yeah, it's happening to mine too.
It's flipping? Let me try again. Let's do stop share and start share then. How about now?
It's still doing it.
It's still blipping. You see the NASA thing?
Yeah, the NASA, the calculator too.
Really? Let's go stop share one more time. I need to keep the calculator there though. Let's try doing this. I'm gonna throw it far away. The NASA we never need again, so I'm gonna literally kill that guy. Maybe this will work. Sorry about that. And let's go to discrete. How about now?
It's good.
Better? Is it better?
Yeah.
Good, good. Sorry about that. It's really hard to tell what's happening. Okay, and I see a lot of chat things, so there's that chat. There we go. Oh, good, got it. Okay, sorry about that. It's hard for me to see, so let me know if things go weird. Okay, so the first row, I'm going to put in, very simple, x. And the second is going to be p of x. When you have a probability distribution table, you could do it in rows or columns, I don't really care, but one row is labeled x, the other row is labeled p of x. X corresponds to the values that can happen. P of x corresponds to the probabilities that those values happen. So let's look at the different values. If the customer gets the base model of the car, what is the profit for the salesperson? Any ideas? What's a profit? Maybe you can put in the chat box or say it. What's a profit for the salesperson? Any thoughts? I'm not seeing you all type it in at once, but hopefully you type in. Okay, so notice that the revenue is $200. The profit is $190 because that salesperson had to buy that $10 gift. Any questions on that? So the profit for X is $190. Is that clear for those of you who said 200? Okay, give you one more chance. How about if they buy the deluxe model? What's the profit for the salesperson? Yeah, $290. What if the customer just goes home and doesn't buy anything? What's the profit for the salesperson? -10. How do we know this? Well, that's how this is working. Because the salesperson gave it out. It says the salesperson gave the gift. So that's the salesperson's gift. Cost him $10 or her. Okay. The probability of a profit of 190 is equal to 0.08. The probability, I'm sorry, not 0.08, 0.12. The next one's 0.08. The probability of 290 is 0.08. What's the probability of a -10? Zero point something. So what's the probability of a -10? Any thoughts? Yeah, it's a complement. Notice that 0.12 plus 0.08 is 0.2. Okay, so there's 20% chance someone's going to buy. That means there's 80% chance the person's not going to buy. So 0.2 8. Any questions? So that's a probability distribution table. Now we need to find the expected value and standard deviation. I worry about this because I'm about to share my calculator, and I hope this works. Let me put out the numbers because I need to see them. 190, 290, negative 10, 0.12, 0.08, 0.8. Okay, so now I'm going to stop share, and then I'm going to do share screen and go for the calculator. And hopefully it doesn't blink on you. Okay, so let's clear out what we had. So now what we're going to do is we're going to go to stat. That's a really important button, by the way. That's the statistics button. I'm going to hit enter. I'm going to clear out L1. I'm going to clear out L2. Never hit that delete button in this mode. Just, it'll destroy you. And then for L1, I'm going to put the 190, 290, and negative 10. And notice it's negative 10, not subtract 10. And then for L2, I'm going to put 0.12, 0.08, and 0.8. Any questions on this? Okay, then I'm going to go ahead and I'm going to hit stat again. I'm going to hit calc, and one var stats is what I want. The older calculators at this point is going to show one var stats, then you're going to hit second 1, comma, second 2, enter. For the new ones, my list is going to be L1. My freak list is going to be second 2, which is L2. Then I'm going to hit calculate. So there's a couple different types of these guys. Any questions on that?
Can you go back to the table? At the values you put into the calculator?
Yeah, I think I just lost the calculator.
It's kind of slow. Mine's kind of slow.
What was L2? I just see on the chat box. L2 was 0.12, 0.08, and 0.8. Basically, L2 corresponds to the probabilities. And you want to go back to the stat, right?
No.
That guy. Right? So we have 190, 290, negative 10 for L1, 0.12, 0.08, and 0.8 for L2.
Okay.
Okay. So it's X and P of X. So it's a table. And again, columns here is a little easier on a calculator.
Okay.
So let me go back to stat. Let me go to calc. One var stats. And it already says L1 and L2. I'm going to hit calculate, and then we're going to read it. Okay. 38, that is the expected value. And then 98.46, let's just call it 98, is the standard deviation. Any questions so far? Okay, so now I'm going to stop share and then start share. And go back to the discrete handout so I can type in the answer. Okay, so the expected value is 38. What we can say is that if the salesperson has many customers, then it is very likely that the average profit per customer will be close to $38. So I want to highlight a few things. One is many. Other is very likely. another is average, and then the other is close to. So whenever you're interpreting an expected value, these words need to be there. So if you don't want to lose points, they need to be there, because all of that, that's what expected value is about. If you look at many of the customers, it won't always be customers, but in this case it's customers, then it's very likely that the average profit per customer will be close to $38. By the way, is that pretty good? What do you think? Those who have a job? You think it might take about a half an hour to show someone a car? Making $76 an hour. Would you take that job, by the way? Okay. Yeah, most people like that job. Okay, are you seeing a blinking calculator? Still are? Sorry. Let's kill the calculator. Maybe that will help. Then we'll have to start again. Away from the shared application. There we go. Try that. It's telling me the calculator needs to move. Okay, let's interpret the standard deviation. So the standard deviation, on the other hand, is $98. Remember, standard deviation tells you how much this stuff varies. Well, if you expect $38 per customer on average, but it goes up and down by $98, that means often you're going to lose money. Okay, and pretty much sucks to have a job where you lose money. Usually in a job you get paid. So what we can say is that because the standard deviation is large, and that was $98, there is no stability in the salesperson's wage. Therefore, we recommend that the salesperson keep a large savings account. Okay. If you're ever doing a business plan, those are the kind of things you have to think about. If you don't have stable revenue, even if your expected value is large, you need to make sure you have capital so that you don't get screwed over when all of a sudden you owe too much money and you can't pay. But in the long run, it's a pretty good job. So it's lucrative with risk. Okay, maybe but risky. Any questions on that? Okay, I think I'm not going to do this one because it's the same, and I'm worried about time. If we have more time, we'll do this one. I want to get to this last one. Okay, so 21.2% of high school seniors have used marijuana. Some survey told me that. Must be true, right? Okay, a study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana. Is this statistically significant? And the hint is find the probability that at least 49 out of 200 have tried it. So notice that each student has a 21.2% chance of saying, yes, I've tried marijuana. Is that clear? Okay, that makes this binomial because it's a yes-no question. Every student has the same probability. So this is binomial, and notice I'm going to just type in some numbers. we're looking at find the probability at least 49. I'm going to type in 46, 47, 48, 49, 50, 51, 52, dot, dot, dot. Maybe I'll do dot, dot, dot before 46. So at least 49 are what numbers? Put in your chat box, what numbers are at least 49 of the numbers that I put up on the thing? Yeah, 49 and up. So in particular, 49 and up are the at least 49. So again, the calculator does not do a number and up. It only does a number and down. So if we want to use the rule of complements, we're going to find 1 minus the probability that x is less than or equal to what number? Okay, not 49, because 49 is in the yellow. We need to find the complement of that. How high does it go up and before you hit the yellow? 48. Have I lost anyone on this idea? So I recommend kind of writing the numbers nearby, see which it is. If you're on the left, you're good, and you're going to go up to the highest number that you've highlighted. If you're on the right-hand side, then you do the complement, and you go up to the one just before it's highlighted. Okay, notice that n, the number of trials, is equal to 200. The probability is equal to 0.212. So I hope you all know how to change a decimal, percent to a decimal. And x is equal to 48. So that's how we're going to use our calculator. Okay, so I'm going to, because I'm finding out sharing the calculator seems to be a disaster on the screen, at least for now. So let me just talk about what we do and see if you can follow along on your calculator. So clear what you got. And we're going to go 1 minus, and then you're going to go second distribution. And then you're going to go up until you find binomial CDF. Hit enter. The number of trials this time is 200. Hit enter. The probability is 0.212. Hit enter. The x value is 48. Hit enter. Hit enter on paste, and hit enter again. Tell me what you get. So put in the chat box or talk. Yeah. So it's about a 14 or 15% chance, we'll call it 15%, we'll round. So about a 15% chance that this would happen due to random chance. So I'm not sure if you remember, but what did we use for statistically significant? What was our standard number? Does anyone remember? What probability must it be for it to be statistically significant? Yeah, 5%. Means less than 5%. Okay, and I'm going to use decimals because that's what the calculator gives us. So is this statistically significant? Okay, notice that our value, oops, 48, the value here turned out to be 0.146. Are we less than 5%? Are we less than 0.05? No, definitely not. It's more. So this is not statistically significant. Any questions on this idea? Okay, so now the question is, would the answer change if you found out later? Where does the 0.05 come from? Is that what you mean? Yeah, that's interesting. It actually came from, I believe it was the 1930s, and it was New York Times. They decided. Didn't come from me, but New York Times decided, and then everyone had to agree because they pretty much were the king of all writing, news writing. So that's where it comes from. So not from math, actually. Okay, so now, would your answer change if you found out later that some students lied and actually 54 of them used marijuana? Okay, because if you think about high school kids, if you ask them, hey, do you use marijuana? Some aren't really going to, say yes when they're using it. Okay, so now let's go do the same thing, but now we're going to have an x equals what? Okay, so instead of 48, what number are we going to use now? Okay, not 54. Take a look. It's very similar to what I have highlighted here. Right, here we had at least 49, and it looked like this. So if it's at least 54, what's it going to be? 53. Does that make sense? Aubrey, you see why it's 53 and not 52? Okay, good. So we're going to do the same thing on your calculator. And you're going to go 1 minus. And then again, second distribution up until you get to binomial CDF. Hit enter. And now you only have to change that x value to a 53. Okay. Why does it actually say 54? Okay, so the way you do statistically significant is you say, what's the probability that it's at least that value? That's kind of the definition of statistically significant. We got 54. What's the probability that it's at least 54? And if you work it out, you get about 0.03. Okay, 0.02995. I'll call that 0.03. So is it statistically significant now? Okay, yeah, so yes, now it is statistically significant. Any questions on that? Any questions? Okay, what I'm going to do now, I'm going to stop sharing. Move this out of the way because that seems to be important. And then I'm going to reshare, but we're going to reshare with the next type. Okay, so now we have something different. Suppose the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. Okay, so a couple things to note. The first thing is that somebody can spend, say, 10.03 minutes. That makes sense, doesn't it? Okay, you don't have to spend exactly 11 minutes or exactly 12 minutes. You could have fractions in between. And when you have that, we call it a continuous distribution. It's not just these whole numbers, but it's the entire number line between 10 and 120. Any questions on that? Okay, next is, this is what's called uniform, which means that the probability of any interval, as long as it's the same size and it's in between 10 and 120, will be the same, whether it's over here or over here. You get the same probability, and that's called uniform. Okay, so if a randomly selected math lab user is observed, find the probability the student will spend between 30 and 70 minutes in the math lab. Okay, so what we're going to do here is, and unfortunately, I don't think I can draw with this program. I don't think this lets me draw. Okay, so I'm going to take, I may have to go to another program. And does it give me that program? Nope. Okay, so I'm just going to have to pretend you're following along. So what you're going to do is draw a rectangle. And the rectangle should have base between 10 and 120. I can show you what it looks like. Let me do it on a blank paper. Okay, I know it's backwards looking, but that goes between 10 and 120. I got a rectangle. Okay, so there's a thing about probability is that you always have a probability of 100% chance that something's going to happen in between 10 and 120. The probability with continuous distributions is the area. So if we want the area, that means we're going to look between 10 and 120, and we want the whole area to be 1. Well, the base is 120. Let's write this down. 120 minus 10, which equals 110. The height times the base must be equal to 1. Maybe write base times height because you're more used to that. Any questions on that so far? Okay, that's your rectangle idea. The area of a rectangle is always the base times the height. So that tells us that 110 times the height, I'll just call it h, is equal to 1. Okay, now I hope that all of you can tell me what h is. Doing some very basic algebra. Okay, I just noticed in this chat, is the statistical significance often manipulated in practical applications? Yeah, I know I could use paint, but I don't have it right here, so I haven't opened it yet. So statistical significance is the most practical application of all statistics. So that's the answer. Right now, I'm just sneaking it in this chapter. We're going to spend the entire second half of the entire course on statistical significance. So just let you know, yes, it's really practical. And use 0.05 as standard. Okay, so what do you get for h? I'm looking in the chat box. I don't see you all typing, but what do you get for h? Yeah, 1 over 110. Okay, we want the probability that x is between 30 and 70. Okay, well, to do that one, I'm going to draw a picture. And I know it's going to look backwards, but there's a rectangle, and you're going to shade between 30 and 70 and find the area of that rectangle. So to find that rectangle, the area, you can do base times height. Which is equal to, the base will be 70 minus 30, and the height is 1 over 110. Okay, any questions on that? And when you work that out, 70 minus 30 is 40, 40 over 110 is 4 over 11. And that's the answer. Any questions on that? Okay, let's do part B. Find the first quartile for the time that students spend in the math lab. Who remembers what the first quartile means? That was chapter 2. And remember? Yeah, first 25 percentile. So now what we're going to do is we're going to draw the same picture, kind of. But this time, we're going to shade in. We're going to have a rectangle. And you got to remember it's backwards. That's all right. And the idea is we don't know the first quartile. We're going to call that x. And we know this area here is 0.25, 25% chance. So now what we can do is, again, the base times the height is now going to be 0.25. Any questions on that? Okay, the base we don't know, but it's going to be x minus 10 because the first quartile is going to go from 10 to what we don't know. So it's going to be x minus 10. And then the height was 1 over 110 is equal to, and the answer was supposed to be 0.25. 10 because this is a box plot. It's not a box plot, actually. This is just it's just a rectangle. This is just a rectangle. So it's 10 because the bottom is 10. So the first quartile is going to have its minimum or the lowest point at 10. And the highest point in the first quartile, we don't know. Let's call it x. So that length is going to be x minus 10. Does that make sense, Josh? Okay. So now you may not like what I'm about to say. It's not that bad, but you got to solve this using algebra. Okay, which is a requirement. What do we do to both sides? So what should we do to both sides on this one? Hopefully you all know. Get x alone, and you do that by multiplying by 110 on both sides. Let me not use the x. I can use the asterisk for times because x is bad notation when we already have an x. Any questions on that? Okay, and now we add 10 to both sides. We get x is equal to 10 plus 0.25 times 110. And you're allowed to use a calculator if you want. And what do you get? I get 37.5. Does that sound right? I just did in my head, which is dangerous. Any questions on that? Okay. I'm not going to go through all of these, but I want to do a couple. I want to do some of these. Okay. How about this last one? Because it's really easy. What's the probability that a student spends exactly 25 minutes in the math lab? Any thoughts on that? What's the probability that a student spends exactly 25 minutes in the math lab? Don't see you jumping in. It's actually quite easy as a hint. Okay, what is the base of the rectangle? What is the 37.5%? It's the answer to this. It's the first quartile, so that means 37. That means 25% of all the students spend between 10 and 37.5 minutes. Okay, or you could also say spend fewer than 37.5 minutes. Okay, what's the probability the student spends exactly 25 minutes in the math lab? Again, we can say the base times the height, right, is equal to the probability. what is the base if it's exactly 25, right? When it was between 30 and 70, the base was 40, right? What about exactly 25 on the rectangle? Then it's between 25 and 25. That's a hint. So what's the length of the base? Yeah, it's 0. So that's going to be 0 times the height, which is 1 over 110. And what is that probability? 0. So that's just a note. Whenever you have a continuous distribution, the probability of it being exactly at a point is 0. And this is something that it's troublesome, because you're used to thinking if the probability is 0, it can't happen. That's not the case. With a continuous distribution, it means there's an infinite number of possibilities and you're only looking at one. So we call that probability being 0. Anyone lost on what I just did? Okay, so let me look at this one. What's the probability that at least 20 of 30 randomly selected students will spend less than 40 minutes in math lab each? Let's do this very last one. Well, to do this one, let's find out first the probability. Just forget the 20 of 30. Let's find the probability that just one randomly selected will spend less than 40. That should be easy, because remember, it's base times the height. And that is equal to, the base will be 40 minus 10. Less than 40 means between 10 and 40. The height is 1 over 110, because that was the height we found a while back. It's the same rectangle. And if you work that out, that is 30 over 110, or 3 over 11. Any questions so far? Okay, that's just one person. But now we're talking about 30 over 40. And the interesting thing about this problem is this is a combination between chapters 4 and chapters 5. This is a binomial distribution problem because every person has 3/11th chance of spending less than 40 minutes. So now we can get our calculator. We know that the trials is equal to 20 of 30, so 30. We know the probability is equal to 3/11ths. And let's just take a look at this again, at least 20 of 30. Okay, this is a rule of complements. So we're going to go 1 minus binomial CDF. And the number of trials was 30. P was 3/11ths. And the X will be, since we want to find at least 20, that means the other side of that is 19 and below. Put that in your calculator, tell me what you get. So there's a mix between the two. That's why I like this problem. Maybe I'll put it in mine also. 1 minus, and then it's second distribution, do up a bunch. Binomial CDF, number of trials now is going to be 30. P is going to be 3/11ths. The X value is, where are we, 19. And yeah, so it's, I like writing that as a decimal, not in scientific notation. I think it says a little more. So that is equal to 0 point, and then 5 zeros, and then 779. I'll just do 7, 8. It's good enough. 779 is not quite the correct rounding, so 7, 7, 8. So very unlikely. Any questions on that? Anyone lost? Okay, the very last bit. All right. Suppose that the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces. And the number of ounces of water that students drink to fill their bottles, okay, in the drinking fountain is uniformly distributed between 4 and 16 ounces. You watch Thorne take a 2.5 ounce drink out of the drinking fountain and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Okay, so again, this is supposed to remind you of something. Let's see, I see something, Josh. Why wouldn't we use a number just less than 40 since the verbiage says less than 40? So let me answer that question. So what's less than 40? The less than 40 is 40 minutes, okay? Not 40 students, right? So it's 20 of 30 students. The less than 40 helps you find the probability for one student. And that's what's going on there. Okay, so the idea here is this one with the drinking one should remind you of something. Here's a hint, more unusually small. That should ring a bell. Any thoughts? The hint is not from this chapter. I always like to bring in old chapters. Any thoughts? How do you decide on how unusual something is? We had a number that helps us with that. We had a way of doing that. I'm not seeing you all jump in. Any thoughts? 0.05, that's a good guess, but not quite. That's to find out if it's statistically significant. But if you want to find out if it's unusual, we use a z-score. Yeah, there we go. Sigi remembers. We use a z-score. Okay, so what we need to do is find the z-score. And remember that the z-score is going to be, if you remember, x minus the mean divided by the standard deviation. And let's make it look right. So the mean should look like a mu. So let's do that. Where are we? This guy. And the F should look like a sigma. And that was a z-score formula. Do you remember that? Okay. Mu is the average of the uniform distribution. And that is just the high minus the low divided by 2, high plus the low over 2. So I'm going to say that mu is equal to the high, I'm going to call that A plus B, so low plus the high over 2. A plus B over 2. It's the average of the top minus the bottom, plus and the bottom. And let's make that mu a symbol. The standard deviation, I do not expect you to have any idea where this is coming from. But it's a formula you probably want to put on your formula sheet. And it's the following. And that is sigma Can you one more down? Okay, sigma is equal to, and then there's a formula here. It's a little complicated. So let's go here and then here. I need a little more too. I need one of these guys and one of these guys. I need to put this in here. And actually, it's not quite that. One more time. Sorry about that. It's the square root of. And then we're going to have a b minus a quantity squared over 12. That's one of those, trust me. That's all I can say. Anyone know calculus? This comes from calculus. Any questions on that? Sorry, it took a moment to type in. Okay, so sigma is the square root of b minus a quantity squared over 12. So let's find these out. Let's start with mu. I'll call it the mean. So the mean is going to be a plus b over 2. Okay, so we got to have, actually, let's go first. So first we just have a drinking fountain. Actually, let's just call it drinking instead of bottle. And the mean is going to be a plus b over 2. In this case, that was uniform between 1 and 8, so it's just 1 plus 8 over 2. And that is 9 halves, or 4.5. The standard deviation, I'll just call it SD, that is going to be b minus a quantity squared over 12. B is 8, a is 1. Okay, so that's 7 squared is 49. I'm just going to write SQRT. That takes forever to get into the formula mode. And we're going to have 49 squared over 12. And that, by the way, 49 squared over 12, we can do that. So that's going to be the same thing as 49 over root 12. And about 14.15. Any questions on that? Okay, 49 squared over 12, yeah. Oh, you know, I did it wrong, sorry about that. It's 8 minus 1, it's just 7 over 12. So it's square root of 49 squared over 12. So one more time. I put the square root in the wrong place on my calculator. Square root of over 12. Sorry, 2.02. That's better. Much better. Any questions on that? So that squared isn't there, I do the square. Okay, so now we can say that z is equal to, well, the x for the just drinking was 2.5. And the mean was 4.5. Divided by the standard deviation, which is 2.02. And we can put that in our calculator. And we get 2.5 minus 4.5 is about -2, divided by 2.02 is around -1. Now for the bottle, the mean is going to be, for the bottle, we said it was uniform between 4 and 16. So it's 4 plus 16 divided by 2. That's 10. The standard deviation is the square root of, so now we have, again, 4 and 16. 16 minus 4 is 12. So that's 12 squared, or 144, over 12. Any questions on that? And that is, let's put it in, 3.46 about. Okay, so now we can do our z-score. So Z is equal to, again, the ounces of water was, where is it? 5 ounces for Preston. So 5 minus 4.5, sorry, 5 minus 10 over 3.46. And I get about 1.4 or so. Negative 1.4. All right, so whose was unusually small? Whose was more unusually small? Yeah, Preston's bottle was more unusually small. Any questions on that? So again, I like to bring in old stuff because it reviews. So I'm a little later than I like to be, but that often happens. So just a note, we need a word. And by the way, there's going to be a secret word today and a secret word tomorrow. So the secret word and the secret word quiz is going to have both. So you're going to have to wait until after tomorrow before you can do that quiz. So the secret word is uniform. Any questions on that? Any questions on anything? Any questions? I'm going to unmute you all because you should be able to talk now, hopefully.
Oh, can you hear me?
Yeah, I can hear everyone because I've unmuted everyone.
Oh, okay. When I was calculating the 49 squared, the square root of 49 squared divided by 12, I didn't get 2.0.
So it's a square root of it's a square root of let's see, where are we? So standard deviation is going to be b minus a. Okay, so b minus a now is going to be 8 minus 1 is 7, right?
Mm-hmm. Yeah.
So it's the square root of 7 squared over 12, which is the square root of 49 over 12. So I did one little part in my head. I did 7 squared in my head.
Oh, okay.
You see that? So that 49 was the square, already squared it.
Oh, okay, okay.
Yeah, that was a 7 squared.
Okay.
I figured it's easier to do it in my head since I know 7 squared. Hopefully you know 7 squared well also.
Yeah.
That sometimes it's easier to do it in your head than use a calculator for little parts of it. Okay.
For tomorrow's lecture, I'm going to be in class. It's going to be on YouTube right later.
This or next or tomorrow?
The project one?
Yeah, the project one will be on YouTube. I recommend if you can have your partner come.
Okay.
Or partners. But if you can't, it will be on YouTube. But the problem is that you won't be able to ask questions while you're watching YouTube.
Well, you can always come into your office hours, right?
You can come to my office hours. You can also post in the project discussion forum. So if it's a project-related question, put in the project discussion forum, and of course office hours. If you live in Tahoe, you can do that. If you don't, you can always post also.
Okay.
Okay. Other questions? And I don't know, is it Melanie? Is that how you pronounce your name?
Melanie.
Huh?
Melanie.
It is Melanie. Okay, I wasn't sure. Okay, so Melanie, did you figure out your calculator, the other issue?
No, it's still tweaking.
Okay, so do a few things. I'm going to do it with you. Do you have anything in the calculator that you care about?
Pardon me?
Is there anything in the calculator that like you program that you care about?
No, actually, I was using the downloaded one. I just got this today.
Okay.
I learned it from someone today.
Okay, you loaned it. Oh, so they might care.
Yeah. I don't think so.
Okay, because there's like a restart everything button.
Okay.
But if you loaned it from someone else, I don't think I want to do that to the other person. You know what I mean? It's kind of like reinstalling the operating system of your computer.
Oh, okay. Okay, you know what? I'm gonna see him tomorrow. So I'll just ask him if I can.
Yeah, because I worry about if it's someone else's calculator, reinstalling the whole operating system of the calculator, because that should work. If not, again, trying to think about what can go wrong. So you went. So did you hit second DISTR? Just hit that button. DISTR is right above tan. It's VARS. Did you try hitting those buttons?
Wait, second and what?
And then the VARS button next to clear.
Oh yeah. Okay, let me.
And what happens when you hit that?
I see Windows, Zoom, GDB, picture, stats.
Okay, so what you need to do is, okay, so you hit VARS without hitting second. So you need to hit the second button, which is the kind of purplish button on the top left.
So clear this?
Yeah, clear out. You can quit, whatever. And then hit the second button, that's like the purplish button.
Yeah.
Hopefully it's purple on your calculator. And then hit that VARS button.
Okay, I see normal,
Good,
PDF.
good. So your calculator is okay. Now hit the up arrow button. Do you see it?
Yeah.
And hit the up arrow button a few more times until it highlights binom CD.
Oh, yeah.
Got it?
Yeah.
Now hit enter once it's highlighted on binom CDF.
Yeah.
And
it says trials P.
Okay, good. So now you're at the screen I was showing you. Remember that screen?
Yeah.
So now you could go back and go through that, one of the examples I gave you. Does that make sense?
Yes.
Okay, so I think the issue was you weren't hitting the second button first.
Oh.
That might be the issue. I'm not sure. It's hard to know exactly what happened on your calculator, but that's probably what happened.
All right, thank you.
Okay, no problem. Any other questions?
Yeah, I have a question regarding last week's homework. I don't know if this is an appropriate time to ask that.
Yeah, sure.
Okay, when I was going through the problems, some of the wording made it really easy to understand a problem, and then other times the verbiage would trip me up. So I was able to get through the assignment and get all the answers correct only because I could redo and populate a new question. So what I'm wanting to ask is there an availability for us to go back and practice assignments that have already been graded so we can go back to the...
There should be that availability. You can't get worse than the score you already got.
Okay, cool.
So even if you get it 100% right and you do it again and get it wrong, it's still 100%.
Okay.
So that's one thing, is while you're doing it, you could do it more. And then you don't have to worry about losing your point. You know what I mean?
Mm-hmm.
And then, in theory, try it, because, again, this is my first time using this. So in theory, it should work. If it doesn't, let me know, because that means I did it wrong or something. You know what I mean?
Yeah.
But it should work. So if things go wrong, I apologize. I know we had a few things at the beginning go wrong. The good news is I have some experts I can talk to.
Sweet.
So I wrote all the problems, but they're the experts on the system.
Okay.
Kind of a teamwork that we've done. And they're using mine for their classes, by the way. So we're all using it, and this is going to go probably nationwide because it's free. But
awesome.
So you should be able to use it in theory. And if you can't, then let me know. You should be able to go back to, say, chapter 1 and try one.
Okay.
Because I tried to make the settings show that it's a little complicated. This whole, for me, you don't know that, but for me to set the settings are really complicated. So I hope I got it all right. There's like 30 different choices. I have to choose just the right combination. So if I got it wrong, I'll try again. Okay. And the other thing is, if there's wording that you can't figure out, here's my recommendation. Do a screen capture on it. Do you know how to do that on your computer?
Yeah.
And post it in the Q&A form.
Okay.
A few other people have done that, and then I answer, And hopefully, you know, I answer, you know, within hours usually. Not days, but hours. So I'm pretty quick.
Yeah. Cool.
Okay, other questions? I think we only have Josh and...
I just wanted to hear the answer to his question.
okay.
Okay,
Any other questions?
No, I think I'm good. But
Okay, then we'll call it a good night unless you have some.
no.
Remember, you could leave by going to the leaving thing. And I'll
Thank
be
you.
posting
Bye.
this online on YouTube tomorrow. Take some time.
Okay, great. Thank you.
Okay, thank you for coming.
Bye-bye.
Bye. Hopefully see you tomorrow at 6.
See you tomorrow at 6.
And for all of you watching this as a YouTube video, thank you for watching.